It's interesting. We talk about reshoring so often, and I'll speak for myself on this. I always assume that's going to look like rebuilding a newer version of what we used to have. So we'll either need to retrofit old factories or build new ones. The decorations will probably be newer. You'll probably have less people in those saggy hats and overalls, and more people wearing typical active wear manning machines. But what if I'm wrong? What if making reshoring possible is going to look completely different? Now, one possibility for making that happen is 3D printing, also known as additive manufacturing. This is something that the defense and aerospace industries have been experimenting with for a while, and so have private companies to a lesser extent. Well, now, the added cost of tariffs and the risks of global supply chains are changing the paradigm enough that maybe, just maybe, manufacturing for parts and components will start to happen through 3D printing more often. Now, this isn't a new idea and it's not my idea. I actually found one CNN article that dates all the way back to 2018 in response to the tariffs on China that were put in place during the first Trump term. So, what this means is it might just be crazy enough to work. And maybe this is the moment. So, in this episode of Art of Supply, I will share how 3D printing or additive manufacturing is being used today and what the benefits are, as well as some of the risks. I'll share what we know about the supply chain for 3D printers and parts themselves, and how the idea of digital inventories may shift this paradigm yet again. I'll also share the findings and recommendations of a brand new research project that seeks to calculate a more accurate cost for each 3D printed project. So, about a week ago, the Wall Street Journal profiled a defense manufacturing startup called Divergent Tech, currently valued at about $2.3 billion. They make vehicle frames, suspension systems, and missile parts through what they call, quote, end to end digital production, meaning that they both design and manufacture with 3D printing in mind. They have customers in the private sector as well as in the military. So they're predominantly focused in automotive on the civilian side. They work with Aston Martin, Bugatti, and McLaren. From a military standpoint, they're working for companies like General Atomics, Lockheed Martin, Raytheon, and the Triumph Group. Now, Divergent Tech clearly recognizes the opportunity of the moment, but their leadership team was also able to see a key risk. So, on the good side, they recognize that companies in the United States would prefer to buy from a manufacturer that is not sourcing parts from China. Now, before the tariffs took place, China was about 25 to 30% cheaper on a lot of these components, but the tariffs have largely closed that margin. But what they realized, and here's the risk, is that their printers, and in fact, some of the parts and supplies they needed to use to keep those printers running, were coming from overseas, in some cases from China. So, what they recognized is that in the supply chain that uses 3D printing, their ability to 3D print in the United States was moving the line on risk and access, but not necessarily solving the larger problem. So, what they're doing is designing their own printers as well as maintaining them using a US based supply chain. Interestingly, when they went to do this, they found that they can't find suppliers in the United States that make or provide what they need. And this is something that a lot of companies looking to reshore also find. The supply base doesn't exist here. So you end up with a chicken and egg problem. Yes, we want the security and lower risk of bringing our supply chains closer to home, but it doesn't exist yet. Well, you need the demand for that, but the demand isn't truly going to grow until an ability to satisfy it exists. Now, Divergent Tech has made the decision to sign long term memorandums of understanding as their way of investing in their suppliers domestically without taking equity in them. And as of right now, they only sell the end product they're designed to produce, not the printer itself. But their perspective on looking at the supply chain required to make, operate, and maintain printers is what made me start thinking about how the crunch and uncertainty of tariffs could potentially give rise to a form of manufacturing that has been awaiting its day in the sun, and that's additive. Now, if we think from a larger picture perspective about the US manufacturing scene, it's been on a downward trajectory since the 1950s. In 1953, manufacturing accounted for about 28% of US GDP. Today, according to the Bureau of Economic Analysis, it's only about 11%. Now, we can look at that same decline in the form of jobs, something that will be critical if we're looking to build this industry back up. In 1979, there were about 17 million manufacturing jobs. As of the early months of 2024, that had declined to a little under 13 million, according to the US Bureau of Labor Statistics. So you can't rebuild in the old way all that easily. I think that's what we're seeing. We don't have ready made facilities. It's expensive to retrofit old ones. In some cases, we don't have the knowledge or the capabilities required to manufacture. We may literally not even have the people. So there's got to be another way if this is going to work. And maybe 3D printing is it. I found different estimates on the size of the industry. According to Persistence Market Research, additive manufacturing is about a $13 billion industry. Another estimate from Precedence Research puts it at about 21.5 billion at the beginning of 2024, and also offers a projection that it may be 125, 126 billion dollars less than 10 years from now. A little less than half, about 43% of it, is currently based on aerospace and defense. But the medical and dental segments are the ones that are expected to grow the fastest. So let's talk about the advantages of 3D printing. It can be done on demand, which reduces lead time, removes the need for excess inventory, and in some cases, even reduces material waste thanks to the ability to create custom components. Eliminating duties and freight and delays brings 3D printed parts into the realm of the possible from a cost standpoint. And in fact, lead time reductions are one of the key advantages. Deloitte reported that during the COVID-19 pandemic, companies using 3D printing were able to, quote, reduce lead times by a stunning 70% compared to those relying on traditional supply chains. They were able to customize and deliver product lines to clients and customers 70% faster. And I agree, that is in fact stunning. But it turns out those estimates may have been low. That stunning 70% was actually less than's being seen now, perhaps based on some of the other supply chain delays we were seeing during COVID. Multiple sources that I found in my reading estimated that the lead time reduction is between 90 and 95%. That is almost eliminating the lead time, not to mention practically erasing transportation costs. So in 2024, the global logistics cost of cargo transport via ocean, air, and land was a little bit less than $13 trillion. Now, if we put that in the context of GDP, that's about 12% of the $110 trillion GDP in 2024. If you could somehow reduce the cost of everything manufactured by 12%, that is massive. Now, there are also process considerations here. Think about the complications of communicating specs to a supplier in a different country and time zone with a different culture and language. In some cases, communicating this to multiple suppliers. If either you have your production segmented or if you have to communicate to this supplier to do one piece of the process and then translate what you've been given from them to another to finish assembly. Now, in a lot of cases, we think about 3D printed components being made of polymers, and many of those are just as strong as metal alternatives. But metal additive manufacturing exists, and it's actually starting to grow. Today, half of the 3D printing in the United States that is metal is made of titanium, which has opened the door to all different kinds of applications. For instance, 3D printing is being used to make rocket parts. It's literally helping rocket science take place. Now, of course, in these highly complicated environments, There are concerns about the micro defects of these parts. But so far, 3D printed titanium parts have passed certification and been able to be put into use. If rocket science is enough for you, how about nuclear power plants? Companies are experimenting with 3D printing to make the components needed to go in nuclear reactors. And many of these nuclear reactors are starting to come back online to produce the high levels of energy required to power AI. But AI isn't just the cause for demand, it's also helping in the process. With AI, it's possible to gather information about every single layer in the 3D printing process. And this makes product quality and traceability far more detailed. In other words, you can actually pre qualify every single part or component before it goes into use because you have the data about its creation. They may actually be safer parts. These data benefits can even extend into design. So, AI powered additive manufacturing is helping optimize design, find defects, and even make sure quality control is better. At the same time, it supports a company's ability to forecast market trends, look at raw material prices, and even get ahead of supply chain disruptions. And that doesn't even bring in the benefits of agentic AI. That will take this even further. It may be possible to design agents that can look at a human created design and provide recommendations for self optimization. Now, all of this sounds wonderful. And of course, there are downsides. Additive manufacturing is just one tool in the toolkit, and it's not going to be a solution for all parts needs. Now, defense manufacturing is very sensitive to risk and less sensitive to cost than the private sector. So it's not surprising that they're among the first to start using 3D printing at scale. Private industry will likely take longer to adapt, but they're on their way. And today, it's less about creating end use parts, but the different components that make it up. Now, this is where we have to understand, as with all other things, where these parts and materials fit into the overall supply chain for a given product. Now, as it is, some 3D printed parts are being made in the United States and then shipped abroad to countries with lower labor costs for assembly. So that negates some of the delay benefits, some of the cost benefits, and some of the risk benefits if we assume that a 3D part is made and then assembled and put into use in the United States. According to Professor Jennifer Johns, a director of research at the University of Bristol, quote, it is not as simple as moving production of X from country Y to country Z. Rather, the relocation of tiers of component manufacture in national territories. If additive manufacturing can reduce the number of component suppliers for any product or component, it will make relocation of the production significantly easier. We know many examples of this, typically motivated by weight and material reduction, but tariffs could drive more serious consideration of the geographical footprint of production. So, in other words, this does not eliminate the need to start mapping your supply chain in a detailed way. You still have to know where everything is made, how far it is going to be moved, how many stops will be on that journey between raw material and sale to the customer. But this factor of cost continues to be huge. And so understanding the cost to 3D print an item is critical. A new study from researchers at the Budapest University of Technology and Economics called Refined Cost Calculation Framework for FDM, or Fused Deposition Modeling Parts, suggests that we've been calculating and therefore thinking about the cost of 3D printed parts all wrong. They break the cost of making a 3D part into 5 components: material costs, support removal costs when you're using a chemical solvent to get rid of the little bits that might be part of a mold but not part of the final item, machine operation costs, which include depreciation, maintenance, and energy. Tooling is the fourth. This is a really important step for them, and we're going to come back to this in a little more detail. And then finally, labor, including the manual removal of those supports if you're not using a solvent. So let's go back to this step 4 of tooling. This is where they're looking to more accurately reflect what the nozzle of a 3D printer is doing during a job. The way that a lot of very simple sort of activist or hobbyist 3D printers work is that it's about the time it takes to create something. Their research suggests that all of this active time, as they call it, doesn't have equal cost because it doesn't all put equal wear on the device. Sometimes a print head is just repositioning itself for the next layer of material. And that's less costly from an operational standpoint than when it's actually putting out material. So when you have a job with a long print time but low material usage, usually the cost for these jobs ends up being overestimated. When ironically, there is less nozzle wear. And so even though these are more sophisticated print jobs, they're actually less expensive in a total cost sense to create. Jobs with a shorter print time that have high material usage, think about a very large, dense, straightforward item. Usually the cost for those is underestimated. So they're pointing out some of the logical flaws in the way that we've thought about 3D printing. If we start changing the way we think, maybe 3D printing becomes a cost competitive option in more places. And there's one more possible paradigm shift on the horizon. If 3D printing means we don't need a parts supplier, we don't need as much inventory, we can have less lead time planning, the idea of digital inventory models shifts the ownership of the design itself. Now, with digital inventory, the advantage goes to manufacturers who have digital workflows and already ready CAD models. With a digital inventory, you don't move the parts or materials at all, just the designs required to make them. Think about it as buying access to a template for a product that's designed to match your 3D printer. It's like instructions. Now, these also have the advantage in that, unlike physical goods, the transfer of digital software files currently that would be used in additive manufacturing are not subject to tariffs. So, in fact, some of the work, the design, even the testing, could go back to one of the countries where tariffs would make it less cost effective to actually import from. This would change not only where the work was happening and access to the information, but it would move from an ownership model of the part to an access or subscription model for the design and instructions required to make that part. Of course, once the powers that be figure out they're being cut out of the loop by digital inventory, they will probably put a taxation program in place to either block that digital inventory or benefit from it. But in the meantime, it is an alternate way to do this that creates a middle path. Now, with 3D printing, the hobbyists and the military are leading the way because they have different motivators. Costs are relative, but it is a huge model shift. So even though the cost and timing benefits are substantial, it's going to take private industry, private manufacturers a little bit longer to commit to this approach. When they do, it's going to be absolutely critical to make sure that 3D printer operators and owners are carefully managing their supply chains so that they don't end up in that situation where the machine itself or a part or a component required to keep it operating is sitting on a dock someplace and can't come into the United States. Of course, big picture, if all of this is going to work, we have to make sure we are thinking about and calculating the costs of these 3D printed items accurately. And so I think it's important that the research into this continues. Now, achieving reshoring through 3D printing wouldn't be the first great new thing to disappoint. But as I said in the beginning, it might just be crazy enough to work, especially given today's global trade conditions.